So we'll see effect of erosion on outcrop strata. So first we'll see in case of fault how the erosion affects the outcrop. So this is a normal fault. This is a normal fault. After erosion, how it will be affected in different condition. So first we'll see on horizontal bed. Color diagram कर दरा. So if any horizontal bed undergo erosion after faulting. So this is your horizontal bed, they undergone faulting. This is your down-thrown block, down-thrown. This is your up-thrown block. So here up-thrown is your foot wall, down-thrown is your hanging wall. So after erosion, the up-thrown part, after faulting the up-thrown part, it will undergo erosion. The up-thrown part will undergo erosion. That means this much part you will see, this will erode and it will level with the down-thrown part. So it will look like this. So after erosion, this much portion will erode because this much portion is up-thrown block. So it will expose the bed to on the up-thrown side, but down-thrown side it will remain unchanged. So now on the both side of the fault, you will get one bed and in the other side you will get two bed. So in the horizontal bed condition, the up-thrown block always expose the older one. Up-thrown block will expose the older one. So always the eroded part, it will be the up-thrown block. Always remember the eroded part will be the up-thrown block, because which is up-thrown, it will undergo erosion. Then if it will expose the older block, you will know that this will be the up-thrown block. Then in case of normal fault, the foot wall is the up-thrown. In case of reverse fault, the hanging wall is the up-thrown. Then comes to dipping of the fault plane. So this is the most important thing. If the fault plane dips towards the up-thrown block, if the fault plane dips towards the up-thrown block, if the fault plane dips towards the up-thrown block, it will be a reverse fault. It will be a reverse fault. So how you will know which one is up-thrown, which one is down-thrown? In case of horizontal bed, the older part, that is a up-thrown block. The older part, that is the up-thrown block. So see, in all these conditions, remember, in case of horizontal bed, only the older part, the older one are always the up-thrown block. So always remember the older one up-thrown. This is up-thrown. This is up-thrown. This is up-thrown. Why the older will be up-thrown? Because it will expose and erode, and it will, after erosion, it will expose the lower bed. So lower bed will be the older one. So up-thrown. So up-thrown. Then you have to find out in any case, if the fault plane deep towards the up-thrown block, it is reverse. If the fault plane deep towards the down-thrown block, it is normal. So either you remember, it is always true. In all type of structure, you have to just find out which one is your up-thrown, which one is your down-thrown. In case of horizontal bed, older younger condition will give you which one is your up-thrown, which one is your down-thrown. In other structure, we will see how we will determine which one is up-thrown, which one is down-thrown. But this statement, it is always applicable. If the fault plane deep towards the up-thrown block, it is reverse. If the fault plane deep towards the down thrown block, it is normal. So see, in this case, it is dipping towards the younger block, means dipping towards down thrown block. It will be normal fault. It will be normal fault. Here it is dipping towards the older block. That means towards the up thrown, it will be reverse fault. Here it is dipping towards the up thrown block. It will be reverse fault. Here it is dipping towards the younger block. It will be normal fault. So in case of horizontal plate, we will get these 4 types of scenario. So in this type of question, you have to first find out which one is up thrown, which one is down thrown. Either you will get up thrown or down thrown. Then we will see what is the dipping direction of the fault plane. Okay. Because if you keep the dipping direction constant, suppose this is the dipping direction. Okay, this is the dipping direction. So keeping the dipping direction constant, a fault can be normal, a fault can be reverse. If you keep the dipping direction constant, it can be normal, it can be reverse. So we have to just find out which one is up thrown side, which one is down thrown side. Next comes to in case of fold. If a fold undergoes faulting, then how the outcrop will be affected by erosion. So first thing you have to understand the main concept, that is, suppose this is an antiform. Suppose this is an antiform. So in antiform, the limb, they dip away from each other. They dip away from each other. If you cut the antiform from here, then the spacing between the outcrop will be less than if you cut it from here. That means as you go down or as you go towards deeper part, the spacing between the limb will increase. The spacing between the limb will increase. That means the outcrop spacing will increase with depth. So if you cut here, they will produce these 2 horizontal line on the surface. So the spacing between them will be less than if you cut towards deeper part. So that means with depth, the spacing between the limb will increase, and also the thickness of the outcrop, it will increase. The thickness of the outcrop will increase. So spacing between the outcrop will increase with depth. So first concept in case of fold, that is in case of antiform, the spacing between the outcrop increases with depth. First concept. And it is opposite for synform, where synform they dip towards each other. So with depth you will see, if this is a synform, see, with depth the spacing will gradually decrease. So the outcrop spacing will decrease in case of synform, increase in case of antiform. This is the key concept here. So from that you will know which one is up thrown side, which one is down thrown side. Providing condition in outcrop, it will be it is mentioned. It is always mentioned which one is your antiform, which one is your synform, because only spacing it will not give you something. You have to you can calculate the type of fault, that is reverse or normal. So it is always given whether it is a your antiform or synform. So this is our antiform, it undergoes faulting. So this is our up thrown block, this is our up thrown block, this is our down thrown block. Okay, so now the up thrown block will undergo erosion. Then what will happen? So after erosion, so the up thrown block outcrop will broaden. The up thrown block outcrop will broaden, or the spacing of the outcrop on the up thrown side will increase. So in case of your antiform, suppose this is indicated in the figure that this is an antiform. Okay, then you have to observe which side it has broader outcrop. Same outcrop, suppose this is the same outcrop. So this side it is broader, this side it is narrower. So this will indicate your upthrown block. So in case of antiform, you have to look, first thing, in case of fold, you have to confirm whether it is an antiform or a synform. First thing, which is given either in plunging condition, either in non-plunging condition. So if you are able to confirm whether it is antiform or synform, then we will proceed the broader outcrop region. The broader part, that will be the upthrown block. So in case of folded strata, in case of antiform, you say after erosion, the spacing between the outcrop increases. The spacing between the outcrop increases. So here the broader strata, a broader outcrop will be the upthrown side. The broader outcrop will be the upthrown side. Then here fault plane dipping towards a downthrown block, it will be a normal fault. It will be a normal fault. So in case of your antiform, the upthrown block it will undergo erosion, and because of erosion, it will expose the deeper part of the fold and the spacing of the outcrop will increase. So the broader outcrop part, it is the upthrown block, the narrower part it is your downthrown block in case of antiform, which is opposite in case of synform. The narrower part will be the upthrown block, the broader part will be the downthrown block. So in synform case, the upthrown side, it will have narrower outcrop thickness or narrower outcrops. So this will be your upthrown part, this is your downthrown part. So it is case of antiform, it is normal fault. This is your reverse fault. Normal fault and reverse fault. So this is antiform case, this is synform case. So this is antiform. From this you will know this is antiform because the limbs are dipping away from each other. Then the fault plane dipping towards the broader region, broader outcrop part. That means dipping towards the upthrown part. It will be a reverse fault. Next comes to in case of deep fault. This also in case of deep fault, how erosion will affect the outcrop. So it is a deep fault because the strike of the fault plane it is parallel to the deep direction of the bed. Strike of the fault plane, this is the strike of the fault plane, and deep direction is in this direction. So suppose we have a bed like this. Okay, this is a inclined bed. So if you erode from surface, then what will happen? Suppose I will erode this up to this level. If you erode this up to this level, then what will happen? So the outcrop exposure will be after erosion will be here. Outcrop exposure will be here because this part will remove. If we will remove this part, then if we remove this part, then exposure will be here. So if you remove further, then exposure will change. See, before exposure was here, then with erosion, the outcrop exposure, it is moving in the direction of the dip. It is moving in the direction of the dip. So always remember, the outcrop of an inclined bed, it advances in the dipping direction with erosion. So this is the key point here. The outcrop of an inclined bed advances in the direction of the dip with erosion. That means in simple way we can see here, suppose a bed here, so it is exposed to the ground here. Okay, so this is the exposure region. As it is, it will eroded, then the exposure will shift. It will shift towards the dipping direction. So in case of deep fault, so this is a deep fault, this is upthrown block, this is downthrown block. So after your erosion, this will be upthrown block. So when it will erode, it will level with the downthrown block. So the outcrop will advance in the direction of the dip. So this will be the fault plane. One outcrop will be here, but the other one will advance in this direction, dipping direction. So here the advanced outcrop, which is moved, or you can say move in the dipping direction of the bed, that will be the upthrown block. That will be the upthrown block. So in this type of outcrop, you can either say these are deep fault, or you can also say these are strike slip fault. Because from this outcrop, this can also produce by strike slip fault. It can also produce by this type of movement. Okay, it will tear down the bed. So it is also a tear fault. So it is a type of, you can say, MSQ question where this type of fault can be deep fault. So first thing you'll see, if the outcrop moved in the dipping direction of the bed, it will be a deep fault or strike slip fault. So in this case, you can say this is a strike slip fault, and here the deep of the bed is in this direction and this thing is advanced. So it can be a deep fault, because from this you'll see the dipping direction of the bed, it is parallel to the fault plane strike. So this is the strike of the fault plane. This is the strike of the fault plane. So this is case of your deep fault. And how will you determine the upthrown block? The part where the bed is advanced. So अगर तुम्हारा bed टा कहीं advance है तो that will be the upthrown block. And if you know upthrown block and downthrown block, providing condition the dipping direction of the bed, dipping direction of the fault plane, you will know which type of fault it will be. So if in this case, so fault plane dips in this direction, suppose, so it will be a normal fault. So if it will be a reverse fault, then this side block is, this side outcrop will move or advance in the dipping direction. So it will be a reverse fault. Providing condition, fault plane dips towards the upthrown block. So in case of inclined bed, so after erosion, how it will affect the block? So this is an inclined bed 1, 2, 3, 4. It is undergone to faulting. It is a normal fault. So if inclined bed first undergoes normal fault, then what will happen? So after erosion, you see the exposure will be here. So before on the ground it is exposing 1 and 2 bed. It is exposing 1 and 2 bed. So after erosion, you will see this one bed will completely missed from the upthrown side. It will be completely missed from the upthrown side. Right. So here will not determine whether it is a normal fault or it is a reverse fault. You just have to know, in case of inclined bed, if a normal fault will happen, there is a chance of omission of strata. So a normal fault, that's why normal fault, it produces omission of strata. So it is a characteristic of a normal fault. It is the characteristic of a normal fault. It produces omission of strata. So any inclined bed, it undergoes normal faulting. It will omit strata on the outcrop. And if you see, if you do a borehole logging, so with the depth on the downthrown block, you will get all the 4 bed, but in upthrown block, there will be some bed will missing. With depth will also some bed will missing in case of upthrown side, but downthrown side you will get all the bed intact. In case of the reverse fault देखा इनती repetition आसे 3 4 5 6 पुन 3 4 5 6 किंतु inclined के देखिए मोर ख्याल पड़ने नाले डायग्राम पे भी अच्छी से डायग्राम में तो भूल अच्छी बुक रे. So देखो, so in case of reverse fault, the main characteristic of the reverse fault, it will produce repetition of strata. So in case of reverse fault, write down. In case of reverse fault, it will produce repetition of strata. So you'll see 3 4 5 again with depth you will get again 2 3 4 5. It will give you a repetition of strata. And always remember, the reverse fault, it changes the order of superposition. Changes the order of superposition. That means, see, so this is your younger bed, this one is your older bed, older. Now here in this case, 4 is older than 2. So reverse fault, it brings the older bed over the younger one. So he reverse the order of superposition. So this is your reverse fault case. Next comes to another concept, that is your nappe. So nappe is a concept where the lower bed that moves on a upper bed. A lower bed moves on a upper bed. It is in case of your thrust fault. This concept will applicable in case of thrust and recombinant. So this is 1 and 2. So a thrust fault will occur. It will, can say, after your thrusting, this bed will slide over to this bed. That means this will detach and move to the top of this bed. It is a thrust fault. It is a reverse fault, where you will get this condition where a lower bed, that is 2 bed, it is moving over. The 2 bed, it is moving over an lower bed. That means in nappe, any type of structure where the lower bed sliding over an upper bed will be considered as your nappe. The example is your thrust and recumbent fault. Example is your thrust or reverse fault, you can say, and a recumbent fault. So recumbent fault and thrust, those are example of nappe. Recumbent fault एमती पाएगा. So this is a bed. During recumbent, it bend like this. Okay. So this will be also considered as the nappe structure, where lower will move over the upper one. So during thrusting, one bed that is the upthrown block, or you can say the hanging wall, it moves and come over the footwall and slides over the footwall for longer time. When thrusting will occur, so this part it will detach, it will slide over this part. So now this block is on top of this block. Suppose see, now this is a bed, okay. Now this bed is thrusted over this bed. This is a single bed. Now if fault occurs and this bed is thrusted over this bed. Now this is your hanging wall unit. This paper is your hanging wall unit, and this is your footwall unit. Okay. Now this block, it can slide over this block. So that's why this is called as your it is like your allo orthotom we can use here. Allo, that is drifted, ortho is your that is not drifted. So this block is moving, so that is why it is also called as your allochotonous unit. Allochotonous unit. So now this will produce a reverse fault and this will move on this bed. It is बुझ पाला ना? So this is called as your thrust sheet. This can be called as your thrust sheet or slices, anything you can say, because during thrust fault what happens, this will detach and a slice will move over it. So this is called as a thrust slice, thrust sheet, anything you can say. बुझ पाला ना नहीं? The hanging wall part you can say this is the thrust part, thrust sheet, anything you can say. So एबे कहाँ होते? Now this part is at the top. ए part कहाँ है? Top रच. Now it can erode. Erode है भाई. The top part can erode. So if the top part will erode, it will expose the bottom part. It will expose the bottom part. Now this top part, it is younger or older? If you see, so this is your younger part. Now it is over it. So this will be younger. Below this paper, it will be older. Okay. Now it will change the order of flow position. It will change the order of flow position. See which file? Next. Now see, if it will erode like this, it will erode like this, the top bed, the thrust sheet, if it will erode like this, so that it will expose the lower part. It will expose the lower part, or you can say footwall part. It will expose the footwall part. So this is called as your window. This is called as your window. It is an erosional hole that will expose the bed on the hanging wall. Footwall. That's why it is called as your window. So these are, you can see on the surface. It is, you can say, an erosional hole on outcrop which will expose the lower bed. It will expose the lower bed, and this lower bed, it is younger. It is surrounded by younger bed. Now older bed. So this part is your younger. Now after erosion, it will expose the younger part. So erosion par se कौन expose करियो? Younger part expose. So the younger part expose करियो. ताहले कौन आवा? एटा है this one will be younger and is surrounded by older. That is called as an outlier. That is called as your outlier. Now think, this thing is only remain from the thrust sheet. This thing is only remain from the thrust sheet, all other part of the thrust sheet, the whiter part, they all erode, only this part is remain. So it is called as your clippe. It is called as your clippe. So clippe, it is an isolated outcrop of the, you can say it is an isolated outcrop of the thrust sheet surrounded by your rocks from your footwall. Surrounded by rocks from the footwall. So this will be the older and it is surrounded by younger. This is called as your clippe. बुझ So this is your thrust sheet. The whiter part is your thrust sheet part. This is your hanging wall part. When an erosion hole that will expose the lower bed, it is called as your window. It is called as your window, or you can say fenster. You can say fenster. Or if all this part will erode, only this part will remain. Some isolated part will remain. It will become clippe. So this is main concept of nappe, clippe and window. तो नोट्स अच्छे तुम्हें देखिदबा मेन कॉन्सेप्ट टा माइंड रखो कौन इनलेयर आउटलेयर when this is older, younger, older. So it is written on the basis of older part. If the older present in the core or at the center, surrounded by younger, it will be in layer. And if older surrounds the younger, it will be out layer. Okay. So in case of faulting, if it is a reverse fault, it changes the order of proposition. So in case of your window is a erosional hole. Window is an erosional hole that will expose the lower bed. That means if this is a window, this will be your younger and is surrounded by older. Younger surrounded by older in case of thrusting, I am saying. In case of thrusting, not in case of fault. If it is a normal fault, window will be different, because window can produce by this normal fault condition. Window means anything that will erode and expose the lower part. If it is a normal order of superposition condition, suppose we have a bed here, like it follows the superposition, it will be younger, it will be older. When there will be erosional hole, it will expose the older one. But in case of thrust fault, that thing changes. So in case of thrust sheet, a window will be an outlier. But in case of normal condition, the window will be an inlayer. In case of normal fault condition or in case of normal situation, the window will be a inlayer, because window simple, it is an erosional hole. It is an erosional hole through which we can see the lower bed. It is an hole simple through which we can see the lower bed. So through a hole that will expose the lower bed. So lower bed is always older. But in case of thrust, that thing changes, because thrust will reverse the order of superposition. So in case of thrust sheet, the window will be outlier and the clippe will be inlayer. In case of thrust sheet, write down always, in case of thrust fault, the window will be outlier and the clippe will be inlayer. But in normal case, opposite. Window will be your outlier in layer, and clippy will be out layer. In this case, so this is your thrust block. It is sliding over this block. This block is stagnant. It is called as the autochotonous unit, and this is called as the allochotonous unit because it is moving. So this is the lower block. This is the upper block. Okay, this is, you can say, hanging wall. Sorry, this is foot wall. This is hanging wall. So an erosional outcrop or erosional hole, if this part will erode, it will expose the lower block. So you can say the exposed part of hanging wall, it is surrounded by the foot wall. The exposed part of hanging wall surrounded by foot wall rock, or you can say thrust sheet rock, and isolated thrust sheet part, it is surrounded by the lower block rock or foot wall rock. That is your clipping. There is a more clear study. So this part, same figure, it is a window, it is a clipping.